side bands. Then if beta is greater than 1, then what will happen? That is the wideband FM analysis. Okay, next, wideband FM analysis. Wideband FM. This is if beta is greater than 1, then that is wideband. Once if beta is greater than 1, first I'll write the reference equation S of t. S of t is equal to AC cos 2 pi FCT plus beta sine 2 pi FMT. This is the FM modulated equation. FM modulated equation. So we want to represent this in terms of frequency domain. In the frequency domain, again before that, if beta is much large, the same equation can be rewritten with the help of the Bessel function. Can be rewritten with the help of the Bessel function. Still, we are in the time domain. Okay, we have not gone for the frequency domain. Please be careful here. That's why I'm still putting S of t only. But we can write in terms of Bessel function. Same equation can be written in terms of Bessel function like this. AC summation n minus infinity to plus infinite jn beta cos 2 pi fc plus or minus nfm into t. So if beta is large, okay, we cannot do any approximation like this. Here we have done some approximation if beta is small. If beta is large, we cannot do any approximation. We have to use the concept of Bessel function. So now I have introduced the Bessel function coefficient here and also summation, infinite summation. Again in the frequency domain, fc plus, instead of fm, I am putting n, where n can go from minus infinity to plus infinite. N can vary from minus infinity to plus infinite. Again, what is the characteristics of this one? See, this j and beta is Bessel function coefficient. This is Bessel function coefficient. Again, you can observe this value is function of n comma beta. This value is function of n comma beta, where n is the natural number. It can vary from minus infinity to plus infinite. That means at which value you are, n can be anything. And also it depends on beta. So the Bessel function Jn of beta is some value. That value depends on n as well as beta. Again, this value may be positive or negative. This value may be positive and also it can be negative also. But if n is even, j of minus n beta is equal to j n beta. J of minus n beta is equal to j n beta when n is even. If n is odd, j of minus n beta is equal to minus j n beta. If n is odd, if n is even, no problem. But if n is odd, there will be the sign change. Okay, so but one thing here, once for a given communication, okay, see, we have defined beta is equal to del f divided by fm. For a given communication, fm is fixed. Okay, the maximum frequency is fixed. Again, for given communication, already they will fix del f. Okay, del f means, what is del f? Del f means kf into af. Once if you design the circuit, kf will be fixed. Kf is the circuit constant, frequency sensitivity of the circuit. Once if you are fixing your message signal, am is fixed, fm is fixed. That means we will fix beta. That means most of the time, once if you have decided for some communication, beta will be fixed. Again, what is the only variable? Only variable is n. Okay, for this Bessel function coefficient, this beta is fixed. What I'm telling, say for example, I will choose beta as 5. How I will choose? Beta is equal to, they are telling del f divided by fm. Okay, they will fix del f is equal to 75k and fm maximum frequency is 15k, then beta is 5. Now, with respect to n, what will happen? If n increases, okay, what will happen? Jn5 value will decreases. After fixing beta, okay, once if you increase the value of the n, again that j Bessel function coefficient value will decrease. That is the main concept here. So again, what is the actual value? For that, a separate table is there. Okay, once say for example, I am fixing 1. What is J15? Again, some table will be there. From that, we have to refer what is the actual value. again, you no need to worry about these values and all, but you should know this concept. Okay, when I'm increasing my n number value, the jn phi, that actual Bessel function value will decrease. That is the main concept, because once if you know that, we can draw the spectrum for this signal. Now I will take this equation. For that, I will try to draw the spectrum. Once again, we will expand that equation. Say we can expand this equation like this. S of t is equal to AC. Say n value I can vary. First n I can put 0. If n is 0, say J0, again beta, J0 beta cos 2 pi FCT. If n is 1, J1 beta cos 2 pi Fc plus Fm. If n is 2, I will get Fc plus 2 Fm. Like that, I can put n negative value also. When n is negative, I will get J1, J minus 1 beta, okay, cos of 2 pi Fc minus Fm, Fc minus Fm. Like this, I can expand this equation up to infinite. Now, how many signals will be there? Once if you expand, n can vary from minus infinity to plus infinite. N can vary from minus infinity to plus infinite. Once you expand, it will have infinite terms. You will have infinite terms. So now I will try to draw the frequency spectrum for this signal. Now I am having individual signal with some coefficient, Now if you draw the spectrum, I will have in the middle, I will have frequency Fc. Again, what is the value of Fc? Fc is having coefficient of J0 beta multiplied with the AC. Again, once if you go to the frequency spectrum, you will get by 2. So this is AC J0 beta divided by 2. Then for the next one, I will have here Fc plus Fm. Similarly, for the next one, I will have here, with less value only. Why? Because once if you increase n value, that coefficient value will decrease. So that's why I am putting less value. So this is AC J1 beta divided by 2. This is AC J2 beta divided by 2. Similarly, I will be having spectrum on the opposite side. Again, for the negative, if it is positive, it is a odd number. 1 means odd number. So I will have a negative value. So this is AC J of minus 1 beta divided by 2. Again, for n is equal, this is for n is equal to minus 1. This is n is equal to minus 1. Again, for n is equal to minus 2, no problem. I will get the positive value only, because when n is even, there is no change. Whether it is negative or positive, both are same when n is even. When n is odd, we will have a change in the value. That sign will be changed. So next I will have is will put somewhat residue. The same thing. Okay, here AC J of minus 2 beta by 2. Like that, I have to expand. So this will expand on both sides, both left side as well as on the right side. So this is the frequency spectrum for wideband FM. Frequency spectrum. Wideband FM frequency spectrum. Now, what you can understand here, see, I can write up to n is equal to minus infinity to plus infinite. Then if somebody asks what is the bandwidth of this system, ideally, the ideal bandwidth of the FM system is infinite. Why? Because that equation is getting extended from minus infinity to plus infinite. That spectrum is available from minus infinity to plus infinite. That's why the bandwidth of this system is in general infinite, but practically we have to define some bandwidth. That's why the Carson have defined the bandwidth rule for practical FM. So now we'll define the bandwidth for practical FM. So what is telling, to define the bandwidth for the practical FM, you take beta plus 1 upper side band and beta plus 1 lower side band. That means almost the entire 100% of the energy will be spread over all the frequencies, but almost 99% of the energy will be available in the beta plus 1 upper side band and beta plus 1 lower side band. So most of the energy available in the beta plus 1 upper side band and beta plus 1 lower side band. Most of the energy is available in the beta plus 1 upper side band and beta plus 1 lower side. That means what is the concept here? Beta is a number. Already I told you beta is a number. Say for example, if beta is 5, you take 6 upper component and then 6 lower component. Only 6 upper component and 6 lower component. That is the concept of beta plus 1. But each component is spaced at the difference of fm. அதாவது fc க்கும் fc plus fm க்கு என்ன ஸ்பேசிங் என்ன fm தான். fc plus fm க்கும் fc plus 2fm க்கும் ஸ்பேசிங் என்ன fm தான். அப்போ if you take beta plus 1 and beta plus 1 upper side band and beta plus 1 lower side band, totally we will be taking 2 times of beta plus 1. Each is spaced at the spacing of fm. So finally our bandwidth is 2 times of beta plus 1 fm. This is important formula you have to remember. For wideband fm, the formula is 2 times of beta plus 1 fm. Now we will just try to modify this equation. We know already the definition of beta. Beta is del f divided by fm plus 1. Again, if you simply modify this, we will be getting 2 times of del f plus fm, or it is 2 del f plus 2 fm. In some cases, suppose if del f is much greater than fm, in some cases it is possible. Frequency deviation is much larger than fm. In that case, bandwidth is approximately 2 times of frequency deviation. Sometimes they will give this also. They will mention specifically in the question itself. They will mention frequency deviation is much greater than fm. Then what is the bandwidth? That time they may not provide frequency value also, because only we need frequency deviation. So bandwidth is just 2 times of del f. So now we'll take for practical fm. Okay, on daily basis we are listening to the fm channel. So that practical fm, the channel frequency or broadcasting frequency of the practical fm, broadcast frequency of practical fm. What is the broadcast frequency of the practical fm? It goes from 88 megahertz to 108 megahertz. In any case, whether you are at Chennai or you are at Tirunelveli or wherever you are, you will be listening the frequency, fm frequency between this range, 88 megahertz to 108 megahertz. And also please remember, fm can be reusable. Fm frequency is reusable. That means the same frequency that is being used at Chennai can be reused at anywhere, okay, around the globe. Or mostly same frequency can be reused beyond 150 kilometer. If I'm using one frequency at Chennai, say 93.5, if somebody is using 93.5 station frequency, carrier frequency at Chennai, the same frequency can be reused at other place. That means, but that place must be more than 150 kilometer. The distance between the two cities must be at least 100 kilometer at least. That means same frequency is used at Chennai, again that is reused in the other part of the Tamil Nadu. Maybe in Tiruchi or Tirunelveli we can reuse. Only FM channel can be reused, but in like AM cannot be reused. Okay, adala or different concept la varudhu, adu nama appuram paapom. But now for the practical FM, the carrier frequency will vary from 88 megahertz to 108 megahertz. Then what is the frequency deviation for the practical FM system? Any practical FM system, the frequency deviation is 75 kilohertz. This is fixed. Mostly in the exam they will ask what is the frequency deviation of the practical FM. So you have to remember this value, 75 kilohertz. Then what is the maximum signal frequency? Already we know that FM is used for sending the audio signal. Audio means combination of voice and music. Audio means combination of voice and music. In general, audio maximum frequency is 20 kilohertz, but most of the information is available up to 15 kilohertz. Almost 99% of the information will be available within 15 kilohertz. That's why we will restrict that frequency to 15 kilohertz. Now we can calculate what is beta. Beta is equal to del f divided by fm. Beta is equal to del f divided by fm. You can get 5. So now for the practical case, what is the modulation index? Beta is 5. Then what is the bandwidth? If we know the beta bandwidth, we can easily calculate, or otherwise 2 times of del f plus fm. 75 plus 15, that is 90k. 120k is the bandwidth of each operator. Again, we have to include, along with the bandwidth 120k, we have to include 20k, that is the guard band. Okay, this 20k is the guard band. Guard band means there will be some spacing between the each operator. Okay, although that center frequency will be occupying plus 90 kilohertz and minus 90 kilohertz on upper side band as well as on the lower side band, there will be some extra gap, that 10k gap on both sides. That is the guard band. That is the guard band. Okay, to avoid interference between the nearby operators, we will be providing the guard band. So in general, the bandwidth of the FM system is 20 kilohertz. You have to remember this. For the practical FM system, the bandwidth is 20 kilohertz. That is fixed because beta is fixed. So once if you fix beta, again you can calculate bandwidth. So all this is about the practical FM system. All about the practical FM system. Practical FM na 88 megahertz la 108 தான் போவோம். அதனுடைய del of 75 kilohertz தான், maximum frequency 15 kilohertz தான், beta வந்து 5, bandwidth actually கண்டுபிடிச்சிங்கன்னா 180 வரும், plus 20 for guard band. So in general, in the exam, they will be giving like 200 kilohertz is the bandwidth of the